There is one more question asked in shift 1 for 2 marks. The question is based on graphs and spanning trees. Right. So, look at this question. This is MSQ. So, G is a this is a directed graph and T is a depth first such spanning tree in G that is rooted at vertex V. So, G is a graph, T is a spanning tree based on DFS. Suppose T is also a BFS, breadth first search, rooted at V. Which of the following statement is true? Here what he has given is, there is a graph. From this, whenever we are constructing spanning tree by using DFS, BFS, we are getting the same spanning tree. So, T is nothing but spanning tree for DFS as well as spanning tree for BFS. So, if that is the case, which of this is true here? Let us try to construct a spanning trees by taking some of the example. This is one of the graph I am taking here. So, this is the graph, directed graph. So, directed graph is asking. So, let us take the directed graph. Right. Let us construct a spanning tree by using DFS. So, what is the spanning tree for DFS? Start from P, depth first search, go till depth, right, 3 number of edges required. So, first these two, then this is the spanning tree by using DFS. Then go for the BFS, breadth first search. So, this one, then in this one we execute all these things, then for the next level, then 3 edges, the spanning tree. Are we getting same? So, DFS spanning tree, BFS spanning tree, same. Right. So, this is what he is asked here. There is a T is a DFS spanning tree. Suppose T is also a BFS spanning tree, then which of the following is true? There are no back edges in G with respect to the T. So, back edges should not be there. That is what he is saying. Let us see. So, in a given graph, this is nothing but our graph G. This is T, this is T. So, if I have a back edge here like this, is there any change in our DFS, BFS traversal? We will start from here, DFS. If you take like this, we will get a cycle. So, we do not take this path, this is DFS is same. Any changes in the BFS, we will do this, start from here, then these two, then this. So, there is no change in the, even if back edges present, no problem. T and BFS spanning tree, DFS spanning tree will get same. No back edges he is saying. So, if back edges are there, it will not create any problem for us. So, this is clearly false. Right. Let us go to the next one. There are no cross edges with respect to T means, if we have assumed this is the graph, if you have a cross edge, anything like this. If you start from here, is there any changes? So, DFS will get in the same way, BFS also will get in the same way. Still now we do not face any problem. Even if cross edges present in the grammar, then also no problem, we will get the DFS, BFS same. So, this is also false. So, he is saying there are no cross edges in G with respect to the T. Cross edges are there also, not a problem. Next one, no forward edges in G. Forward edges means, if I have an edge directly like this, directly this way, then we will get a difference in DFS and BFS trees. So, forward edges when once present in the graph, then DFS, BFS difference will be there, we will not get the similar things. So, this is clearly should not be there, forward edges should not be there. So, this is true. The only edges in G are the edges in T, that is false. This is spanning tree, so edges need not be same here. So, this is also false. So, here clearly our required statement is nothing but there are no forward edges should not be there if you want to get this requirement. This is the question.